So, hello dear students, now let's start with the next numerical. Here you are given 50 centimeter cube of hydrogen which is collected over water at 17 degrees Celsius and 750 mm of Hg. Now here they are asking calculate the volume of a dry gas. So here the hydrogen is collected over water, so it will be the containing moisture, and due to moisture what happens with the gas is it increases the vapor pressure. So to identify the volume of a dry gas, what we need to do is we need to eliminate this vapor pressure due to moisture. So now P total, that is total pressure, will be equal to pressure of the gas plus vapor pressure. So here P total is given to us is 750 mm of Hg. Vapor pressure is given as 14. So pressure of dry gas will be 736 mm Hg. Okay. Now P1 what we are having is P1 is equals to 736 mm Hg. V1 we are having is 50 centimeter cube, and T1 we are having, small t1 is 17 degrees Celsius, so capital T1 will be equal to 290 Kelvin. Now they are asking us that this should be calculated at STP. So at STP, P2 is equals to 760 mm Hg. V2 is the question mark, and T2 is equal to 273 Kelvin. So now very simple, apply combined gas law. What will happen? P1 V1 by T1 is equal to P2 V2 by T2. Okay, so now here we are having 736 multiplied by 50 divided by 290, that is equal to 760 into V2 divided by 273. Alright, so that implies V2 is equal to 736 multiplied by 50 multiplied by 273 divided by 760 into 290. So my answer will come around 45.5 centimeter cube. The answer. Now let's go ahead with the next one. Here they are asking us which will have greater volume when following gases are compared at STP. So the comparison must be done at STP. Now here given first gas, which is nitrogen gas at 25 degrees Celsius and 748 mm of Hg, and second gas is given oxygen gas which is 1.25 liter, but it is already at STP. So here we need not to calculate the volume of oxygen at STP, but we have the volume of nitrogen which at different temperature and different pressure, that we will bring to STP. How will bring? Answer is very simple. See, you are given V1 equals to 1.2 liters, P1 is equals to 748 mm Hg, and T1 equals to 25 degrees Celsius, so that is equals to 298 Kelvin. Now they have asked us to compare it as STP. So P2 will be equal to 760 mm Hg and T2 will be equal to 273 Kelvin. So at this temperature we have to compare. Now how we will compare? See, apply combined gas law. P1 V1 upon T1 equals to P2 V2 upon T2. So here see, P1 is 748 into V1 is 1.2 divided by T1 is 298, that's equal to P2 is 760 into V2 we need to find, and T2 is 273. So that implies V2 is equal to 748 divided by 760 multiplied by 273 by 298 into 1.2. Okay, so now if you see carefully, 748 by 760 the value will be less than 1. This value will be less than 1, and 273 divided by 298, again the value will be less than 1. So now when two values which are less than 1 and you multiply it with 1.2, so V2 will be less than 1.2 liter, is for sure. V2 will be less than 1.2 liter. This is for which gas? For nitrogen gas. So nitrogen gas volume will be less than 1.2, and here if you see carefully, the oxygen gas already given 1.25 at STP. So therefore what we can do, oxygen gas is volume is 1.25 liter at STP. So it is very clear from this comparison that oxygen gas will have higher volume. So therefore O2 will have higher